Hello, everybody, and welcome to this wonderful webinar where with Modal, where we're going to show you how you can use Kestra and Modal together to create powerful workflows. My name is Will. I'm a developer advocate at Kestra, and I'm joined today with Charles from Modal as well.
Hey there. Yeah, my name's Charles. Studied neural networks in my PhD and have ridden that wave to now be developer relations and AI engineering at Modal.
Very, very cool. So to start with, I'm just going to give you a brief overview of what Kestra is for those of you who maybe haven't heard about it. So Kestra is a unified orchestration platform. So it makes building workflows super easy. Now you can do this both declaratively in YAML, but you can also do that from the UI. So it sort of helps bridge the gap between sort of technical people and non-technical people who might want to try and do the same thing. So you might want to build workflows where a non-technical person might want to also run those with different parameters, but you don't need to be technical to use the tool. On top of that, you can also do cool things with interactive conditional inputs, which we're going to talk a little bit more about today, where you can build workflows that can change very flexibly without having to, show loads of options to your users at the same time. So we'll show you a little bit more about that in a bit. Now, something that makes Kestra really cool is that we have a huge variety of plugins, and that's actually where Modal comes in really handily, because we have a Modal plugin that makes it super easy to connect Modal to Kestra without having to go through loads of hassle and setup. So hopefully, if you've thinking about building some workflows, there's a plugin for you in Kestra. But if there isn't, then let us know, and we might consider building it in the future. On top of that, we also have a bunch of blueprint examples to help you get started. So that includes some modal ones. So if you want to, get started with the modal plugin, we have some pre-ready to go examples to get you started too. And as I said earlier, in Kestra, you can do everything as code and from the UI. And so if you're someone who prefers to configure things, manually, then you can do everything in YAML, which is my personal preference. But you can also use the user interface form to be able to add different options, properties to your workflow. And I'm going to walk you through a little bit of that as well today too. So you kind of get the best of both worlds, and it makes it really easy to build complex workflows effortlessly. Now, I'm going to hand it over to Charles to talk a little bit more about Modal and how Modal makes things easy.
Awesome. Yeah. So yeah, thanks for that overview, Will. Yeah. So where uh, Kestra is about sort of like orchestrating and like combining together a bunch of different, data sources, operations you want to do on data. Modal's about making it easy to access the the compute infrastructure, the like hardware, the storage that you need to run your applications. So if you could go to the next slide, Will. The like our tagline is that we let you run code in the cloud without all the agonizing pain. So you might have so our target audience is like definitely a developer, somebody like building software themselves, not the like consumer of Kestra primarily through the UI. So like look at in my head when I think about how people use Kestra, I imagine there's like some people who like consume it through the UI, and they're kind of like they're maybe running regular reports. But they want lots of knobs because they have lots of questions they want to like ask and answer. And then on the other side is somebody who like stands up something like that for maybe a stakeholder or an executive or somebody else to work with. So the problem that you have is like if you're, data scientist working on something, you like get some cool demo going that runs some cool new Hugging Face model and like helps enrich user reports with like interesting information added by a language model or whatever. And then you got that running in a Jupyter notebook, and now how do you turn that into a service that can be like integrated with Kestra, orchestrated with Kestra, that you want to run it with GPUs, maybe because you're running a language model, or you've got a diffusion model that generates images, and you need GPUs to run that, but you don't want to pay for a GPU all the time. You certainly don't want to have a GPU per workflow that you want to run every single time. So Modal makes it possible to get a GPU for 1 second, or like 10 seconds, or 50 GPUs for 30 seconds each. Just sort of like very flexible serverless infrastructure. And so the thing we found that people really love to do, like it's very generic infrastructure. You can do all kinds of things with it. The thing people really, really love to do is like get a hold of like GPUs in particular, for like the fanciest, schmanciest NVIDIA GPUs, like H100s, for short periods of time to run these cool new open foundation models. Um, and so what makes there's lots of people who like provide infrastructure. Like you could go to AWS for infrastructure. You could buy your own computers if you wanted for infrastructure. So why Modal? That's on the next slide, Will. Um, the like key thing about Modal is that we like rewrote the container stack, the stack for delivering this to you,
I love that you
like
say
in
in Rust,
scratch.
by the way.
In Rust, by the way, the tester, just to let you know, Andy Lamb, who works on Data Fusion, said like one reason why he thinks Rust is great is because it attracts a lot of young developers who really want to write Rust. People will like fix bugs for you for free. So yeah, so the thing is, like, there are other serverless infrastructure providers. So sorry, just to double click on that term because maybe people aren't familiar. The idea with serverless is that instead of you needing to think entirely in terms of like virtual machines that you administer, that you stand up and tear down, which you might be familiar from EC2, or like managing like physical machines, like buying laptops, installing stuff on them, running things on them, plugging them in. Serverless is like a level of abstraction on top of cloud servers where you describe the functions you want to run. So you write Python code, say I want to run this. And that's the level of abstraction between you and the infrastructure. So you don't think about the server, you think about the service or the function. And so there's like a thick stack there. Like obviously there are physical servers. There's an operating system. There's all these things, and we wrote a large chunk of that stack to be compatible with existing tools, but just 10 or 100 times faster. So there's a great talk from our co-founder Eric Bernardson about how we built our own scheduling system, container orchestration, something similar to Kubernetes, and our own like Docker, our own open container initiative compliant like container runtime, just to make stuff fast, to handle really really big images that have neural network weights in them or large data sets in them, to be able to handle really big inputs and outputs. There's just like a bunch of things that just don't work super well for data intensive workloads. The kinds of things you tend to put behind like a data dashboard, they just don't work super well. You can try and map them onto AWS Lambda if you like, if you enjoy pain, if you enjoy like writing your own like 302 redirect wrapper around in a lambda around your lambda, that sort of thing, is what you need to make these things like work robustly, and that's the stuff that we've built to make it robust and snappy. So yeah, so bunch of components there. Maybe like this one's a wild one. I don't know, Will, if you see people doing this sort of thing on Kestra. One is like we spin up sandboxes to execute code in, so you can have a language model generate code on Modal, then like run, then it generated code. It could like rm-rf itself. It could like delete itself. You asked it to write another poem, or you asked it once again to like how do I install CUDA drivers, and it's like, you know what, I'm just gonna uninstall myself, and we've all been there. So
Yeah.
that like you don't want that to run in the same place where your language model server is running. So we do sandboxing. It's basically what we're doing all the time. We're like sandboxing people's code. So why not just sandbox any kind of untrusted code? Um, like, yeah, scale that out, run 100 different copies of programs written by LLMs, run them all against your tests at once to find the one that works. So like not just like, oh, let me get GPUs, not just, oh, let me run models, but let me have this like flexible infrastructure primitive that even as a data scientist who's not a Kubernetes expert or a certified AWS data warehouse forklift operator, I could use this infrastructure. That's the vision.
Nice.
So yeah, we have a blog where there's actually now we added an article on using Modal with Kestra, but we also so contributed by Anna. Shout out to Anna at Kestra for writing that nice article. But there's all kinds of things that you can do with this that you could put in as like services to call from your Kestra workflows or steps to add in your Kestra workflows. Everything from pulling down satellite data from European Space Agency satellites to running a stable diffusion model pipeline or running your like an analytics stack composing DLT and DBT together on Modal to do your like data analytics. So lots of blog posts, lots of like sample code for you to check out to see like all the different things you can now access via Modal.
Nice. And for those of you who have used Kestra before, you could think of this like a task runner where instead of having to run things as a sub process on your Kestra instance, you can then deploy them in remote compute environments. This is just a sort of another task runner you could think of. But there's definitely, like you were saying, Charles, we've definitely had it where people have run everything as sub processes and they get a huge clash of dependencies between different things and it gets really messy, right? And, Modal does a really good job of being able to just take all of that headache away and just allow you to run your code, right? You don't have to deal
Yeah.
with trying to get it all to work together nicely.
Yeah. That's maybe we'll see some opportunities to call that out when we go through the
Mm,
examples. But that's one of the like in one of my projects, it's a fake social media site full of LLMs. As part of that, I scraped the New York Times archives to give them something to talk about. And I have a separate container image just for installing just the like Python New York Times API wrapper, so that I don't have to like learn the API, figure out all the like edge cases to work with it. But also, I don't have to worry about that library needing like request version
mm,
1.17.5 dev 0 like Tuesday, March 3rd, right? Like I like if it wants to be that specific, it can be, and I set that thing up as this like separate environment and sort of like interact with it as a service. And I found like when using workflow orchestrators like Kestra, it actually can be really nice to separate out like the workflow orchestrator does all this work on like just making sure that data is coming from the place it's supposed to come and going to the place it's supposed to go. Once you start like mixing a bunch of code logic like directly in the workflow orchestrator, things start to get messy.
mm,
You have mentioned lots of sub processes calling each other or lots of dependencies. You can sort of like set them up as these external services that like interact with your workflow more the way that you interact with something like the OpenAI API for language models or an external database that you pull information from, where it's like, oh, it's like this piece of infrastructure that's like sitting there ready to go, this little machine that you've set up that like takes an input, spits out outputs, and it's like nicely walled off from a bunch of the other kinds of
mm.
components of your workflow. And that used like just speaking as somebody who's, as I said, like a researcher, PhD, not a software engineer, Modal has given me like the software engineering powers without having to go the hard way of learning the like all the details of AWS. I have managed to forget a bunch of bullshit about Kubernetes operators that I tried to learn. Yeah.
I must say that if you are using task runners in Kestra to deploy on like AWS or whatever, just being able to deploy your Python in Modal is like way easier. No configuration. You just have to put your ID and token, and we'll show you that in a minute. And it just works. It just works. It's very very easy. Let's have a look at the demo that we have in mind for today. So, like we said, we're going to use Kestra here to sort of manage the whole process. And as you can see here, we've got loads of different steps here. So with our workflow, we're going to have that set up with a schedule. So we can have it run a couple of times a day using a cron expression, quite straightforward. And then when that will execute, that's where Modal comes in. So we've got a Python script that is going to run some simple forecasting. And that forecasting is going to happen entirely on Modal. Now, for that to happen, we've got a data set on Hugging Face that we're going to pull. So if that ever changes, whatever, we can get the latest version at the beginning. Then we can start to transform that with pandas and then start to build and train a model with a stats model where we can then plot that forecast onto Plotly, turning it into a HTML file, send that over to S3 so we can see the file. And that's where Kestra can come in to then like send us a message and go, hey, by the way, your end results here, click here, and you can have a look. So you get the power of Modal, but then the sort of nice interface of Kestra. So let's jump into that and have a look at what that is. So jumping into Kestra, for those of you who haven't seen it, got a lovely dashboard here. It shows us how successful things are and how bad I am at writing workflows sometimes as well. But we're going to have a look at some of the example workflows that we've got here. So to begin with, here we've got this wonderful, simple example here that uses the Modal plugin. And
Mhm.
as you can see here, we've got our Modal token ID and secret, which we can
Will,
just
would you mind zooming in for me there, just
yeah, no
so I can
problem.
read that text there a little better?
Is that a bit easier?
Yes, perfect. Thank you.
Perfect. So here we've got our first task here, and that is using the modal CLI task. Now, if I click on the documentation tab here, and when I click on that, it will bring up the modal plugin info so I can find out exactly a few examples. So here's a really simple one that just does hello world, but I can scroll down and see the properties too. So I can see which properties this task needs to make sure we get it set up correctly. Now, this is very similar to some of the script tasks. So if you've used the Python script task or maybe the shell script one, very, very similar where we have a file called gpu.py. Now, this could be saved as a namespace file like we have here, or you can write it in line and then sort of input it here. So you can say here, this gpu.py file here is actually just this in line. So we can have a look at that in a second. But then we can just run a command just like you would on your own personal machine. And in this case, we're going to run the modal command to get it to run on modal. And all we've had to do is run the modal command and set up our tokens and a little bit in the Python code that we'll show you in a minute. But other than that, it's fairly straightforward. None of this having to, dig through the AWS dashboard for hours on end. And it's still charging you a fortune, even though you didn't do anything. So let's have a look at this Python code. So here, actually, Charles, do you want to sort of jump in here a little bit and talk about
Let me jump in. So with modal, the like usual flow, I think, pretty much the main thing you'd be doing with these, with using modal run, that's the sort of thing that works really well with these like workflows, because it's like I'm going to define a function, I'm going to find the infrastructure it needs, and then I want you to that says like run this thing like one time, and so that's what you would use as like a workflow step. We also do like deployment. That would be like if you wanted to set up something somewhere else, like outside of Kestra, and then like use it inside Kestra, the way you use like other external services. But yeah, so focusing on a modal run, you write a Python file, and you like looks like a normal Python file. You are you might define some function like this. Let's actually focus on the like print GPU info function first.
Mhm.
So like this is the kind of function that you want to run. Like you want to this if you've never used this like GPU stack before, all this stuff is doing here is actually this is just like a quick warm up check. This is what I would do like the first time I use a machine. Like I've been installing stuff and I want to make sure, do I have GPUs available? Like, and what do they look like? That's the subprocess.run NVSMI. And then check some things about Torch and CUDA and their integration. That's those like print statements there. So that like block of code there is something that I want to run, and I take that and I decorate that function with a modal decorator to say this is actually something that I want to run on the cloud. So that's that app.function decorator there. And then inside of the arguments to that decorator is where you put like the kinds of infrastructure needs. So here we're saying, I just want a GPU. Any GPU will do. You can also add things like, oh, I need access to secret information. I want access to this S3 bucket. I want like to talk to a distributed file system. There's like all kinds of stuff you can put in there. Um, but yeah, for now we're just saying, oh yeah, I need a
Mm.
GPU. I'm testing that. So that at the beginning of that decorator, there's that at app there. So that's a Python object that describes the like application, which is like in Modal, it's kind of like a collection of functions that all like have some relationship to each other. So for example, all of them have by default the container image, the like dependencies defined on that line above, line 18, with the image equals blah 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 right there. So that's the way that you define like container images, which if you're familiar with container images, this is sort of like a Pythonic interface to building Docker files, or like writing a Docker file, that would say things like, oh yeah, I need to start from a particular base operating system. I need to like install these. There's a bunch of footguns with Docker files that we kind of avoid by giving you this high level interface. In the end, it's something that's like basically looks like a Docker file is what we run. So if you're familiar with that, you should find, like, you can bring your existing Docker files, you can use registries, like you can do all that stuff if you want, but we've just given you this high level interface. If you're not already a container person, then like what this is doing is saying like, what does the file system, what does the like computer look like when my function starts? So you're saying here, we're just saying start from like this Debian Slim, that's our like base, sort of default base operating system, and but sort of system setup stuff or system level stuff, and then pip install, so Python install this torch library. And for this example, it's like, oh, I want this specific version of torch. I want like torch with CUDA 11.7. That's just there to show you like, oh, you could kind of do fancy installation stuff with this. You don't like lose any power. Um, so that all that sets up, like, this is also where you would set like environment variables that you need to have like everywhere. What are some other things you do in Docker files?
And
Yeah,
we'll
like
have an example with the environment variables in our next one, so we can show you
great.
what
Yeah,
that
we'll
looks
see
like
that.
too.
We'll see that. Yeah. So that, like, you can also do that per function. Like if you want, like, the New York Times API example that I said, like you can have a function with its own image definition. And we build it once and then we'll like hold on to it, cache it, make it fast. And yeah. Uh yeah, anything else I want to say here? So yeah, that's the modal app. So then like this is everything needed to run that code. Like all you need is like a modal secret so that you can authenticate to us and like, swipe your credit card for the infrastructure. Because like, like when you think about it, like people will say like, "Oh, code, here's everything you need to run my app." It's like, well, actually, like that's not everything. I need to like make sure that I have this library installed and that library installed. I need it on a computer with a particular shape. Like
Mm.
all that stuff. So there's like kind of like a sort of like reproducibility, reusability thing here to like putting all of your infrastructure in Python. This would be like more easily portable, perhaps like across workflows, because it's just a single Python file and it's like the application and its infrastructure all together. I see a question from Mahul in the audience. Will
Yeah,
Oh, look at that. StreamYard. I love StreamYard. I don't
it's
use that
so
much
good.
myself, but man, it's so nice. Great. So how do you manage dependencies, error handling, and scalability when orchestrating complex workflows across distributed systems? Yeah, so I can answer this maybe, Will, like with a focus to the like modal aspect of it, and then maybe if
Yeah,
you want to talk about like where Kestra comes in. So with
yeah.
dependencies here, my primary way of thinking about it with modal now is I try and isolate things from each other and only communicate between services with like, strings or bytes or like an agreed on like JSON format, so that I don't have to make sure that like my like one component of my system that cares about talking to the database needs to know what a torch tensor is so that it can talk to my embeddings, like the embeddings part of my system, which then like, I have a front end for displaying it. Now that needs to know what a torch tensor is, and then now they all need to agree on the same type of torch tensor, like it's a torch 1 tensor, not a torch 2 tensor. Like put an L in the chat if you've been burned by either the NumPy 1 to 2 transition or the Torch 1 to 2 transition. It's painful. So like just separating these things out, and then Modal makes it easy to like just define those dependencies in line or bring in like requirements.txt files, and like it's right there next to the code. You could see it when it breaks really straightforwardly, and then like the interfaces are all like relatively simple. And then for scaling, like Modal will automatically like we'll scale up additional replicas up to 100 CPU containers, up to 10 GPU containers on our free plan. And then like spin them up and then spin them down. Takes a second or two to spin up a new replica on top of any work you need to do. So that like means like when something comes in, a bunch of people come in at once, scale up your infrastructure, and then like once they go away, we'll scale it back down. You have parameters to control that to do like a cost performance trade off. Do things like keep some things warm all the time just in case traffic comes in soon, but then be ready to scale up when it becomes like when traffic intensity increases. So there it's scaling is hard. I'm not going to say that Modal's like a silver bullet for scaling everything, but I think for data intensive Python workloads, we figured out a bunch of sensible defaults and the right like levers to hand you to do a good job scaling. Like I've scaled LM inference API. Like just last night, I had like 100 H100s going at once to run a bunch of browser agents, and it like spun up transparently and spun back down on Modal. Error handling, I think error handling is super tricky. I think like error handling is exceptional control flow. Nobody really gets this right except maybe the hardware. And even then, I don't know, like error handling and signals is like one of the worst parts of Linux, like worst implemented. So like it's hard to get this one right. I think what I'd say is like yeah, Modal will like reveal errors, and you can decide to pass errors back. That tightly couples your interfaces. Trying to pass errors around like couples your interfaces, because now when you get an error that's like a PyTorch error, like that's gonna have a bunch of PyTorch specific information in it, and so you can't like pass it back to some like thing that talks to a database. So like what the hell is a tensor? I only know ORMs. Like what are you talking about? And so that makes error handling really hard in these systems. With Modal, my preference is to sort of define things like sufficiently robustly that I can re-execute things on error. So it's like if an error happens, it's like it's logged somewhere and I can like replay it or like rerun the job and know that I won't like double spend on a credit card or like double enter into a database if there's an error. Um, and or yeah, sort of like one nice trick actually is to like log these things into a database where they could be like reviewed like asynchronously from the production of the error, and then like hook that up with some Slack notifications like every day, show all the errors in your system. There, like I guess once you get to the point where you're building one of these like a distributed system, you're building a big workflow with lots of steps. You must be doing that because you're at a certain scale where now like one row failing is probably not a like pager duty like get me up like problem like stop the world. It's the sort of thing that you need to like keep an eye on and tend a little bit. This is the like cattle not pets thing in cloud infrastructure. It's like have something that you can kind of like manage in bulk, not something where you like have to take it on a walk every couple of hours or it pees on your couch. And so that would be my like though it's like it's like almost like a cultural engineering change of like switching over to like fault tolerance and like asynchronous error handling and like a statistical approach to error. That's I think your best bet. Yeah, anything to
Yeah.
add, Will, on like on what Kestra brings to solving that problem?
Yeah, so in Kestra, you can add some error handling itself to your flow. Now, this is a bit more high level because it's not necessarily going to be able to catch specific Python exceptions. But if you've got multiple steps to your workflow, maybe Modal's just one step of many. And if Modal fails, or if Modal doesn't fail, it's not actually like, an issue for later down tasks in the pipeline. So you can allow your, Modal task to fail and for the for the workflow to continue, but you can also tell it to fail and completely crash. Now, when it does fail, we can add a separate error block, and I can kind of give you a quick example of what that might look like. We can add a separate error block here, so it's quite similar to the tasks one, but now we can add another list of tasks that will happen when an error happens. So if this does fail, I could easily just put like a simple like log message. I could make it, a Slack message, for example. Great. Doesn't want to tell me it's a Slack message, fine, but you get the idea. You can I'm on the developed version, you see, later. Hit or miss if it works, but yeah, you can add like monitoring, so like you could send a message to PagerDuty, for example, or you could tell it to maybe like do some different parts of it. So you've got lots of flexibility there on like how you want to manage it. It was obviously quite difficult when you're working with Python code, for example, to be able to like do things of when certain exceptions happen. You can send some outputs from your code back to Kestra so that Kestra then knows maybe why something happened rather than just that it failed, full stop. So you can then get a little bit of flexibility, but otherwise, you can build sort of a bit of infrastructure around it so that if it does fail, it doesn't just like waste a bunch of your time. Something else that's really handy about handling errors and stuff in Kestra is if something does fail, and this task is maybe not the best example because it only has one task, but if I was to run this quickly and we see this run in action, when it finishes running, there's this option to replay a singular task. So if you were to write code, badly, we all do it. It happens. No one's perfect. And you've got, further down the pipeline, right? And you're on your third out of your four tasks, and the first three took like ages to run, for example, and you don't want to rerun them. They were fine. You can rerun that later task with a newer revision of the code. So if you've got a newer version, you fix the code problem in your Python script, but you don't want to have to like go through those long tedious steps earlier on. You can then like replay it and then pick a different revision. So that's another way that kind of Kestra can help you deal with some of those issues. If you do run into them, you can get notified that you had a problem. You can go in and fix the problem, and then you can easily replay it without having to jump through the whole step again. So there's a few things like that that just kind of make it a little bit nicer. Anyway, we've now just run our task, so I think we should talk about that a little bit as well.
Yeah. Maybe let's jump into the fuller task. Like we've really like found a universe inside of a nutshell on this
I
example.
know.
But it'd be nice to see the full one.
Yeah, so in this task here, right, our Python code is just here quite nicely in line. Now, this is a bit of a love-hate relationship for some people. Some people look at this and go, I would never write Python inside of YAML. Why would I ever do that? And I respect you guys. Like, fair enough. You don't have to do this. You can instead, if you would prefer, you can copy all of this. We can easily just create a gpu.py file and we can paste it in here. And, oh, it's all indented because it was in YAML. Let's just fix that. There we go. So we've got our, Python code like we would expect. Now, if I go back to our workflow here, I can get rid of all of this now because it's in our namespace file. But in order to be able to access the namespace files, and again, this is where some of that dependency management comes in, I have to be able to enable it. So I can just set this to true. And now this task will be able to see those files. We can also set it to specific tasks files too, if you want to make sure that this task can only see the file that's relevant for, if you want to make sure that if there's something that's, secure, you don't want other tasks seeing it for different reasons. Like you said earlier, Charles, if you don't want to accidentally have one task accidentally wipe all of the other namespace files, you can control that a little bit here too. But now it's a lot cleaner to read. We can easily see that here we've got our type. We've got those environment variables that we talked about earlier that we can get from the modal dashboard. And we can actually jump into the modal dashboard and have a look at what that might look like. Charles, you will have to remind me, is it just under secrets that I can get those things, or do I have to go somewhere else to get them?
Are you looking for, so the apps is where I would go to see the thing that just executed. So example GPU 3 minutes ago. Yeah, that's your call there. You can see, been trying out both examples. Yeah, so you get like, for a single execution, like these logs are going to be relatively, relatively minimal. You see there's just this like one call. You can chain together lots of function calls, do lots of things in a single modal run. So this is the output from that job that we ran. So that's, we can see the, maybe zoom out one time. And I think that might make this look
There we go. Is that better?
No. Quick view in context. Let's give that one that's probably a better choice.
Is that going to make it wider? There we
go. Much nicer. That's what you like to see. So this is the output saying like, oh yeah, like we have a GPU, we have like an NVIDIA A10 in particular, the like driver information, wattage, utilization, and then all of that like Torture CUDA information. One thing I do want to call out, I guess if you've installed these things in the past, like you know how painful it can be to like, conda install the CUDA drivers. Like that's all stuff that we handle for you as like the like underlying manager of the machines. Like if you ask for a GPU, we're gonna give you like our latest like the latest CUDA drivers, backwards compatible, and like and like hook all that stuff up so that all you need to do, like for the like happy path of most like GPU applications these days, is just do some like pip installation, and
Mm,
you'll get everything you need without needing to worry about the like system installation. Um, yeah, so cool. So yeah, so this is like you got logs for your apps. You can find you can see like which ones have been like you like deployed if you want to like deploy something to access from multiple workflows. You can look through your storage if you want to like save files from one workflow and then read them from another. All that is visible from this dashboard.
very cool. And if I was to get my token, I get that from in the settings menu under API tokens. Is that where
Yeah,
I can
yeah,
generate?
yeah,
So I can easily generate my token here. And
yeah,
then all I've done in Kestra is I've created these as a key value pair.
yeah.
Now, you could think of this like a secret, but it's not a secret because it's definitely not. It's definitely stored in plain text. So you shouldn't use this, but this is available in our open source version if you want to be able to just do something that means you're not putting it directly in your workflow. If maybe you're syncing it to Git, for example.
Mhm.
But if I go to namespaces and we go to the one that we're using, I can just see that I can just quickly create that key value pair, put the key in here. I can paste in the value that Modal gave me, and now I can access this. We
Yeah.
also have secrets that are available, which is in our enterprise edition, which I
Mhm.
would prefer to use. But for this example, we're using the key value store as that's something that anyone can use. But you can also just paste it in directly if you know you're crazy and that's how you want to live. I'm not going to stop you. You can put it directly in as a string too. So once you add those environment variables, then this, and you can add other environment variables. You're not limited to just these two modal ones. You can add other ones, and then those will be able to be accessed inside your Python code. And our next example actually kind of walks through this quite nicely.
Yeah.
Um, but yeah, anything else you want to talk about in this example? Should we have a look at the
No. Yeah, let's take a look at the forecasting example.
perfect? So here is our forecasting example. Now I'm going to zoom out just a tad, just so it's a little bit easier to see. So actually, I'll go to just the topology view. So here is our workflow. It looks a little bit more complex than what we just had. But what we've got here at the top is we've got two different schedules. Now, these use a cron expression. So think of them like a cron job. You can give it your cron expression and they will run, but you can also add a few extra conditions as too if you want it to only run on maybe weekends or on certain public holidays. There's lots of flexibility you can do there beyond just a normal cron expression. Now, I've actually got two schedules here, one that's going to run in the morning and one that's going to run in the evening. And I can, see that quite easily here, and we can click into those in the editor in a minute. Then we've got this if statement that's going to ask us, do we want to run this code on Modal? Yes or no. If we say yes, then it's going to run it on Modal. And once it's finished running it on Modal, then Modal will upload it to S3. And then there's a S3 task in Kestra to download it back from the Modal server so we can then view it inside of Kestra. Because the results all good being in S3, but then we have to go to S3 and find it. And that's a hassle. So we can, add a task here to pull it straight back. So very, very convenient. Now, jumping into the workflow. Now, in our latest release of Kestra, we released these things called conditional inputs. Now, this is awesome because before, if you had a complex workflow that had loads of different inputs, but some of the ones later down were only relevant depending on what you ticked further up. So maybe if you said like, I want to do this, yes or no. If you said no, then everything else is, irrelevant because you're not going to use those inputs, but you'd have to display them anyway. So it meant that you'd get this execution page where you press execute and it just give you this big list of stuff, and half of it wasn't relevant. And this isn't great for people who maybe aren't super technical, like I imagine most of you watching, because they want to be able to just run the forecasting model and see the output. They don't necessarily want to see loads of different details that maybe aren't relevant to them. So this makes that really, really easy. And we can use it's all done with this depends on property here in our input. So we've got a list of our inputs here. And these are just parameters that we can pass in at execution. So we can change how the execution works. But in this example, we can say the data set one only shows if we say we want to run it on Modal. So if I press the execute button here, if I press false, everything just disappears all of a sudden because we don't need that information anymore. So it just makes that interface really nice. But if I do select true, we can now see a load of more different things. And the same for the forecast parameters here. When I click true here, again, we get loads of different information that is irrelevant if we press false because it's just going to use the defaults. But previously, you'd have to just see all of those default values, which, isn't the end of the world, but it just makes it a little bit easier for being able to run in here, click the important bits and ignore everything that isn't required. So we'll go back to the inputs in just a minute. So we've got tons of different inputs that allow us to customize the forecast that's going to happen on Modal. We've got our if statement that's going to check the input value here, which is just a simple Boolean. So it will just see if it's true or false. If it is true, then that modal CLI task that we're familiar with, we can see that here. And it's using the same modal run command, but there's a lot more going on here where we're passing a load of different parameters and we can pass the data, the value for those parameters using the inputs. So Kestra effectively gives us a really nice interface for this command line prompt. So quite useful there. We can also specify a container image and then a bunch of environment variables too. So last time we only had those modal ones, but here we've got AWS ones that we need for being able to use S3, as well as being able to specify the GPU and memory that we want to use too in those Python decorators. So lots going on here. And then lastly, at the bottom here, we have that download task. This is where, again, we can prompt it to find just the HTML file, which is an input. So handily, we can then use an expression to access that at the bottom here. And then that will download it as an output, which means we'll be able to access that later on in the execution. So we'll show you that in a little bit. And then I talked about those triggers. Again, we have the two triggers here, and you can see they're just using a cron expression, nothing, that you've not seen before. But you can customize these, as you can see here in the pop-up. You can just do, if you want it to run daily at midnight, then you can just do @daily if you would rather do that. But then this can also pass inputs in too. So we can say, I want this specific schedule to use these inputs when it runs, and vice versa. And then again, different cron expression here. So very, very handy. Now, jumping back to those inputs, these are all relevant to how this will execute inside of Modal. Now, I'm going to open it up in the execution page because it's a little bit easier to follow. Now, we've got the data lake URL that we want to use, and this is where we've got data stored in Hugging Face. We've got two different files. We've got a Parquet and a large. We can swap those and sort of play around with that. Now, this is where Charles was talking about where we can select use different GPU types on Modal. Here we can say any and just let Modal decide what it's going to use. Or if we want to get specific, we can do that too. We can also select the amount of memory. So maybe if it's a super large model, we want to be able to select as much memory as possible. But maybe if our wallets aren't very big, we want to maybe keep things on a smaller scale just to manage costs a little bit more. So we can do that too. And then if we go to the customized forecast parameters, now we can change the name of the file if we want to, but we've got a default value pre-entered in here, so we can ignore that. Same for that HTML file. And because it's an input that's used as an expression further on in our task, if we change this, then when it downloads the file from S3, it will be looking for the same file. So we don't get into an issue where we've named it in one place and it changes, the name's different in another. It will be able to update in all the places. So we can maybe change this to be something else. And then just simply, if we want to change the colors of the graph so that they maybe are more colorblind friendly or easier to see, or I don't know, match something else to your requirements, then we can do that quite easily here. Maybe we change the colors if we've got different graphs we want to compare to easily show which one's which. And as well as the forecasting days. And we've got this nice little picker here that means we can easily change the value, or we can just type in, 100 days if we would prefer. So tons of different inputs here. And the conditional inputs makes that really easy because it allows us to make various ones depend on one another without having to, clutter this huge screen. Because imagine if you open this up and you're like, whoa, I don't know what I need to fill in here. This is all a bit, intimidating. I just want to get my forecasting model and have a look at the data. I don't really care about anything else going on here. But luckily, that's where the conditional inputs makes that a little bit easier. Let's jump into the Python code and have a look at what's going on there. And maybe, Charles, you can sort of expand on what you were talking about earlier, and I'll zoom in a bit more as well, where we can see some more of that stuff that we saw sort of snippets of in the first example, but we can see it sort of fleshed out a little bit more here.
Yeah. So, passing some information off. So, kind of fun thing with Modal is like there's two Python environments. There's a local environment, which is where which is like Kestra is running for you. And then there's the remote environment that Modal is running for you. So this like modal.secret.from local environ is like a way to pass information from the local like OS environment variables up to the remote OS environment variables. So we have that there. That's yeah. Keep going. Maybe look at the image. Yeah, we're installing a bunch of stuff. Um, I tend to be a little bit paranoid with these with the pip installs here. So what's going to happen is like the first time that you run this, we'll build this image for you, and we'll like pip will resolve all these down into version numbers. You know, pandas 2.5, you know, pi arrow whatever 0.11. Um, then like if somebody comes along and runs this again later and they like change something, they add a new dependency, like that's going to run again. We're going to like reinstall all of those things, and those dependencies might change. So depending on how you want to do it, if you want to keep the like bleeding versions of the libraries on here, then or if you're just doing like a quick one-off script, you don't have to put the version numbers, but you put them right in there just the same way you would on the command line, like pandas like greater than 2 or something. But yeah, that's like yeah, going down maybe to our next our predict order volume. So this is like a um yeah, this is our the function body there is like the work we want to do on modal. The decorator is saying excuse me. The decorator is saying like what kinds of like infrastructure do we want? And here we're like passing that from the local Kestra environment, and that's like we're getting that from the workflow, and so allowing the consumers of this workflow to say like, oh, you know what, this one is really time sensitive. I want to run with the GPU and get this answer quickly versus like, oh, you know what, I'm just running this one every night at midnight. I'm not going to look at it until the morning anyway, so like run it without the GPU. Right. And then yeah, so you can pass in whatever arguments you like. It's like
And these all
easiest.
came from the command line. Where is it? Let me find it. These
Yeah.
all came. So these were all of our inputs that we passed as parameters in that command line call,
Yeah.
and then we can access those here as well.
Yeah, so you can use the way we're using modal in these cases is like there's just one modal function in a file, and then like you modal run the file, and like you just get a command line interface into that one single function. You can have multiple modal functions in a single file, and then you would do like modal run script.py like double colon predict order volume, or it would be like script.py double colon like download files. Like you could split these things out into separate functions. And then if you wanted to find something that you want to do just when you just like modal run script.py, you can add a little local entry point, app.local entry point in another function to say like, okay, first call this function, then take the outputs, like do something, make a decision, okay, then call this function. And so you can have more complex little like kind of internal logic with these scripts if you want, the same way you do with like a regular Python script. But like Modal's kind of designed to have lots of different like levels to hook into it, so we're hooking in at the simplest one, which is just like
Mm,
write a function and then modal run, and you get like a command line interface to a cloud deployed version of that function. um
very
yeah, and you
cool.
can see maybe one last thing I'd call out is like the input types here are all strings. The output types is like a tuple of strings. That's like pretty common once you start like creating little services, like microservices style, setting up these things. You tend to go for these simpler types. I kind of mentioned this in response to Mahul's question on dependency management. It's like, yeah, like I'm just gonna like whatever my predictions are gonna be, I'm not gonna keep them as a pandas data frame. I'm not gonna keep them in this like sort of complex Python object. I'm going to find a way to like write them out in a simpler format, like a pair of strings. And I'm going to have my inputs be strings as well. You can run modal where like the local client also has pandas, and then like you sending data frames from local to remote. That's sort of like a thick client approach as opposed to a thin client approach. That's
Mm.
a like a term from kind of like distributed systems design. So it's up to you how you want to do it. If you're just using modal to offload intensive computations, then it makes sense to maybe do thick client, and then you have to make sure you have that like that full Python environment with pandas or whatever locally. Um, but yeah, the code here is like there's not anything too crazy going on in the code if
Mm.
I remember correctly. It's like
No, it's just a simple ETL that does the
yeah,
forecasting.
yeah. ET train load. Yeah,
Yes, mini bit of training in the middle.
yeah.
But yeah, we're using data frames here to get that, the dataset URL, which we handled as an input in Kestra. Data frames is reading that in and starts to process it here. And we can see that data frames is doing some of the transform step here. And then a little bit further down, we can see it starts to train that model here and starts to predict what our forecast should look like. And then once it's done that, we can see that it then starts to generate that HTML file with a graph where we can then view it. So we can see here it's using Plotly to be able to create that. And we can see that it takes in, let me find it. It takes in the colors that we asked it to. Here we go, the color prediction, so that we can, again, have a relatively interactive Python script here without having to change, in the command line directly. But this is also handy because when you're running with different schedules, you can set up all these different schedules that will pass in the parameters for you. So you can get different data at different times or whatever, if you're into that. Or you can set up something more event-based that triggers this when maybe a certain event has happened, maybe a file has arrived in S3, and then you want it to take that file and then process that file. You could set it up like that too.
Yeah.
So yeah, then we can see it creates that HTML file. Is there anything else you wanted to sort of brush on? I know I just went through that quite quickly, but
Yeah, I mean, the one thing I would say is like another way to do this in Modal would be to use Kestra, would be to like deploy a little web server that has this HTML report in it. So
yeah.
you would use something like Fast API and just serve this as a static file. So Fast API is really great. It's very welcoming and comfy, like introduction to web serving. For Python, it's like great docs, very friendly community. But then it actually also is like quite scalable. It's like
Yeah.
single threaded asynchronous execution, same way that like Node web servers work in Python, but done in Python. So great for like a data scientist who wants to like dip their toes into like serving and making web apps. Then you could like put that HTML page up, maybe like, or use something like the Fast HTML library to make an interactive Python like front end around this report. And then like Kestra would like kick this job off and then like run modal deploy to like deploy that web server that has this HTML report where you can like click through and maybe like change the data and retrain the model, or like see a bunch of past predictions from past runs and compare them to each other. Like kind of add some more like additional features, and like Kestra's there to make sure that you like run that deploy every week, and so the data is always up to date, or to allow somebody to change the parameters and then like and re-execute and redeploy without having to change code. And that's like for if you were building like a more featureful thing around this report, that's probably the way you do it. But it turns out, S3 is actually also a great static file server. I don't think anybody runs a website off of S3 anymore, but that used to be the hot way to do a static file servers for busy people. So that's I think our move here.
Yes, yeah. But no, this is, if you're doing this properly and not just as a quick demo, definitely, you'd rather deploy your modal app rather than upload a file to S3, then re-download it from S3 and then view it locally on your machine. But we are looking at adding the support. So when this uploads to S3 and downloads it, we can then view the HTML file inside of Kestra. So you can sort of preview it rather than having to download it and reopen it. That's not available just yet, but we are looking at getting that supported at some point. So yeah, after it's created that HTML file, we can then upload that to S3, like we discussed. And then this is using the Kestra library here to then provide us a bunch of outputs that we can see nicely in the UI. But we could also use those outputs in later tasks if we had them. So maybe if we wanted to send a Slack message, we could specifically say, the name of the file. We don't have to, we can pass that in as an expression. So lots of options here to be able to use Modal to do the computation and then pass a bunch of data back to Kestra that we can then continue to use further down the line. And then this is just the entry point. So this will produce that HTML file in the logs, and we'll see that when we execute this. I reckon we should give this a go and see what it does. So here, that's the name of my S3 bucket. You can see here, I have an S3 bucket called that. It's empty at the moment, so that's a good sign that they haven't run this yet. So we'll see that fill up in a minute. And then we're going to just keep everything as standard. We'll use this data set. Do you have a preference on GPU, or should I just leave it to any?
Put it to an H100, baby. Let's rip.
A H100?
Yeah.
All right, let's do it. Okay.
I'll make sure you get credits, for the dollar or two we spend running this forecast on an H100.
Oh, hopefully it's quick though. And then we'll leave all of the names of the things and the colors the same, and we'll front execute. So here we get the wonderful Gantt chart that shows us the if statement has continued and modal is now executing. It's creating a Docker image locally on Kestra to start that up. Like we said, there's the local version and then the one deployed in modal. And then here we've got this nice URL that when I click that, I can see that this is running on a H100 GPU inside a modal without having to go into the modal dashboard and figure it out. Gives me a nice little link there. And we can see that this is going away like crazy. And if I go, and it succeeded because it was so quick at doing it. And we can see in the Kestra logs here, the information it did print out as we expected. It's also given us a URL to go view that as a success. And then it deletes the container that was running it locally on Kestra. And then at the end here, we've got that S3 task that says it has done that on S3. Now, if we go to logs, we can actually set this to trace. And I'm sure if I go down to the S3, and I didn't produce any trace logs, but what we can do now is go to this outputs tab. And in here, this is where we can see the different things generated. So here under modal, I said about those different parameters that we have, those different outputs. It has then just given us those as a sort of key value pair here. So we've got a HTML report, is forecast.html, etc., etc. So I can see all of that data here really easily, which is very useful. And then to get that file, we've got it here and it's given us this thing. Now preview doesn't work, but I can download it and then I can open it up here. And actually before we go too quickly into it, if I refresh this, we can see here that forecast HTML and forecast.parquet have arrived in our bucket conveniently. Now, if we go back here, we can see that this is generated our prediction, and we can see that based on what it's seen, the red is what it thinks is going to happen in the future, and we can easily zoom in on that as well, which is kind of nice if we want to get a little bit more info and whatnot. I haven't really used Plotly, to be honest.
It's nice. Yeah,
it looks quite nice. I've only ever really used Matplotlib, so this is whoa, this is way nicer than that.
yeah.
Cool. What was the other thing I was going to show? Oh yeah, so because we are getting towards the end of time, we have another flow here that is event driven. So because we're uploading things to S3, what we can do is use an S3 trigger here to then notify us when the file is ready in S3. And when it notifies us, it will send us a link to Kestra so we can then go and view the file in Kestra so that we know it's ready. So now if I was to run our first task again, and we'll, let me find it. What I need to do is increase the font size of just the editor rather than all of Kestra, because it just makes everything very hard to use. So if we execute that again, I'll just leave it to any today. Let's see that execute. So again, we're going to see what we're familiar with. And if I actually go to the executions page, we'll see that it is executing here. No problem. It will take a little bit of time. So where we wait patiently now. Here we go. We can see that it's running, but it has now detected a file in S3, and as a result, it has created. If I refresh that again, it did actually fail, ironically. Don't know why, but a file did end up in S3, and now if I go to Slack, we can see that Slack did in fact get a file, and also an error message. This shows you the error message handling you can do in Kestra as well, in case you're curious. And it tells us about exactly which execution failed. But if I click onto here, I can see under outputs, this is the execution that triggered that's the S3 trigger. But if we were to go to the forecast and go to the last execution, I'm actually curious, why did it fail? S3 just decided it didn't want to work, but modal worked. That's the key thing, is that modal worked.
That's good.
And the file would have ended up in S3. The download here doesn't really matter if it's just telling us that the file is in now S3. And we can see that when I refresh this here, we can see that the trigger moves it into the archive folder for us. So we can see that the trigger did work. So this is quite useful if you want to be able to have a workflow automatically trigger when a file is received, it processes the file and then it can move it to a different folder or a different bucket or something to show like this file has been processed without, or you can delete it if you're crazy and you don't care about data integrity. You can delete the file too, and maybe you want to because it's massive and you can't afford to store all of them. But yeah, it's kind of an example of where you can use the event-driven nature of Kestra, kind of combined with the power of Modal to create kind of very complex workflows that sort of suit whatever needs you have. Charles, anything else you wanna add to this?
No, I just say Modal's free, and we also give you $30 a month of free compute. That's like what's that? 6 or 8 hours of an H100 or 30
Perfect.
hours of an A10 GPU. You can run a couple like always on Python API servers if you want. And don't tell anybody I told you this, but you actually can torrent with the if you wanted to say down, operating systems are frequently distributed using peer-to-peer torrenting technology. So there's actually a number of potential applications there. Yeah, so $30 a month free compute to take the platform for a spin. Our goal is to make this like absolutely the best developer experience for building like Python applications on the cloud. And so like we take user feedback super seriously. We have a Slack where you can come and talk to us. Like if you ask a question in the Slack, there is still a pretty solid chance that one of our co-founders will respond to you. So that's always fun. And yeah, we're trying to we think we've got like really solid bones here on this infrastructure, and we want to make sure that we like build the tasty flesh around it in the way that people want. So make sure to yeah, don't be a stranger. Share what you build. Also, we have like a GitHub repo with cool things people have built on Modal, like a Git server, like replace GitHub
Nice.
with something running on Modal. That's a bad. That guy was like, disclaimer: this is a bad idea, but it's cool. And that and like a tarot deck generator powered by like Flux diffusion models and language models. So yeah, if you build something cool and put it out in the open, like let me know. We'd love to like promote it, share it, and yeah. Oh, if you have a startup, we do up to 25K in credits for startups to try out the platform,
Nice.
build
Think of the
out
amount
your
of
infrastructure, make
H100
sure it
time you
works.
could get with that.
Yeah, you know the H100s are they consume matrices and dollars very quickly relative to other computers. But yeah.
Very cool. Very cool. Well, thank you very much, Charles, for joining us. Really appreciate it. Definitely
Thanks for
check
having me,
out
Will.
Modal. As you can see, really, really convenient to use, even in Kestra. If you've got, Python, if you're doing a lot of Python data stuff, then definitely check out using Modal inside of Kestra. And yeah, I saw your Slack. I saw just how like vibrant your community is. So yeah, definitely don't be a stranger. Check it out. And yeah, thanks everyone for watching. And yeah, follow both Modal and Kestra for more information on all things Python data and orchestration.
Awesome. Yeah, I'm on Twitter. Find me. DM me about the cool things you build.
Very cool. All right. Thanks, everyone. Bye.